This is a solutions video for Math for Liberal Arts. I know this is practice test, but this is actually the real test right here. And this is over chapters 2, 3, and 4, spring of 2012. First question here, very straightforward, multiplying fractions. It's realizing you multiply straight across. So 9/8 of 1/3 is 3/8. Number 2, you're going 180 miles an hour. What is that in miles per minute? You just have to do the conversion here from hours to minutes. And if you got 3 miles per minute, that's great. If you didn't, and didn't show any work, I gave you no credit. And that's pretty much the case for the whole test. If you showed work, if you missed the answer, I will give you some partial credit if it was correct work, obviously. So 180 miles an hour is 3 miles per minute. Don't recommend going that fast. Number 3, you just got to realize that the fraction bar here is division. So 2 divided by 11 is 0.18 repeating. 4, multiply like bases, add the exponents. So that's going to be 10 to the 11th. And when you divide like bases, you subtract. So 9 minus -6 gives us 10 to the 15th. 6, density is mass divided by volume. And so it's 5 kilograms. And the volume is 6 liters. So it's going to be 0.83 kilograms per, I don't know what that should say, liter. And yes, that should float. If that ratio is less than 1, it would float in fresh water. Number 7 here is if I had 10% increase and then I get a 10% pay cut, how does that compare? So if let's say I just had $100 here and I get a 10% increase, that's 110. But then if I get a 10% decrease, which is only 90% of that, that's actually going to be $11 off, which gives me 99, which shows that I'll actually have a net 1% less in this scenario. But so the 10% of a larger number is more of a discount, so that's why this ends up being less salary. Number 8 is just a conversion here with the consumer price index. So you want to go 1997 is 160.5, and that's 515 per hour. How does that compare to 2000, where the consumer price index is 172.2 compared to X? So we cross multiply and divide here. And so $5.15 in 1997 is the same thing as $5.53 in the year 2000. Number 9, this is a little tricky. The key here was to look at the second quantity is the reference value. So we're going to compare based off the second value here. So we find the difference, the absolute difference is 140, no big deal. And then how does that compare to 1160, which gives us 12.1% of that? If we compared it to 1300, it would have been a lower percentage, but it said use the second quantity as the reference. How does it compare to that particular value? Number 10, if you had 10% each year for 10 years, will you earn exactly twice as much? And the answer, it's false, because you get compounded interest. So the 10% increase the second year would actually be more than the year before, and then more and more. So it'll actually be way more than double your salary. Number 11, this is a compound interest. There's a couple ways to do this. I suggested just using the compound interest formula, and that was the hint. If I just invest $1 for a year, compounded monthly at this rate, what do I end up with? And so the APR is 5.2%, but the APY, the yield, will actually be a little more because you compound monthly, which gives you 5.325. And you could have actually used the formula from the sheet as well, but we didn't cover that as much in class, so I suggested this method since we did this formula many times. But both ways will work fine. 12, you're supposed to calculate payments on a loan. So here's the payment of a loan formula. There's the principal, there's the rate, it's monthly. And so if you do this, if you showed all this work and you accidentally didn't quite type it in right, I gave you a partial credit. So it's $816.28 a month for the 30-year mortgage, and the 15-year mortgage at a 1% lower rate gives you just a little under $1,000 a month. And if you put that out over all the payments, the first one's going to be $293,860 for that loan, and the other one's only $179,983. So you save, almost $113,000. by paying it off in 15 years instead of 30 years. So obviously, which is better, the 15-year mortgage. On this one, you're supposed to figure out how much money do I need today to have $161,845 when I retire. So we're going to use the present value formula. So trying to figure out what is this worth now, presently, if in the future it's worth this. And there's the calculations, and so if I have $8,629.45, and I'm able to let it sit there for 42 years at 7%, I'll end up with that $161,000. And this formula is what do I need to put in every month, assuming I have nothing right now. So this is calculating for the payment to achieve a future value of this, and that's the A. And then so this is same calculations, a little bit different. Get the -1 here. And then so if I put $53.17 a month in for the next 42 years, I'll end up with, at 7%, end up with the same amount, 161,845. On 14, when you are paying off a loan, the first payment is amortized. Most of the money goes to the bank. They make sure they get their money first, so most of it goes to interest, and then each month you pay, that ratio keeps changing towards being less for the bank and more towards your principal. So it says, is it relatively high? The interest is relatively high and principal is low, and that would be true. And the last one here is scientific notation. Just move the decimal place 7 places, 2.3 times 10 to the 7th. Hope this video helps prepare you for the final or for the test in, well, this current semester you might be watching it in.